Hello all, welcome to the video. In this video, I'll break down this RAG architecture pipeline step by step, so you understand exactly how RAG works from raw documents all the way to the final AI answer. So what is RAG? RAG stands for Retrieval-Augmented Generation. And why do we need RAG? We need RAG because normal LLMs often guess or rely on outdated training data. RAG fixes this by first retrieving relevant up-to-date information from external sources like documents, internet, feeding the context into LLM. This grounding step helps the model give more accurate, reliable and current answers. So let's understand this architecture diagram. Data sources. These can be PDFs, website, documents and databases, etc. There we go into data ingestion. This just means collecting all the raw data into a pipeline so we can process it consistently instead of dealing with dozens of formats manually. Here we have pre-processing and cleaning. Here we remove noise, extra HTML tags, duplicates or anything that will confuse the model. Next comes chunking, a very important step. Instead of storing huge documents, we break them into smaller text chunks. Chunking is crucial because the retrieval happens at chunking level, not at whole document level. After chunking, we pass each chunk into an embedding model. The embedding model converts text into high-dimensional vectors and their metadata are stored in a vector database. Next, the query phase, which runs when a user interacts with your app. The query is passed into a query embedding. Just like we embed the chunks, we embed the user's question into same vector space. Then we perform a similarity search against the vector database. The idea is find the stored chunks where embeds are closest to the query embedding. Returns the top k chunks, the k most relevant pieces of the text. Those chunks will go into prompt augmentation. Here we build rich prompt that includes both original and retrieved context. That augmented prompt is sent to the LLM generation. Now model is not answering from its training data alone. It's grounded in your actual documents. Finally, the model's response becomes the final answer that the user sees. Let's build a simple RAG application. Here we are using Colab to build our RAG application. First, we need to install necessary libraries. We are building the simple RAG application using LangChain, hence the necessary LangChain libraries needs to be installed. Sentence Transformers is a Python library that turns sentences into powerful vector embeddings for semantic search. We are using Faiss vector database, and PyPDF is to work with PDFs, and requests library is used to send HTTP requests from Python to websites or APIs. Second step, we will import our API key which is in the user data. We are using Colab because it is very easy at beginner level. Many popular ML and data science libraries come pre-installed. We are using Groq API here because it is free. Now let's understand how you can create your Groq API key. Log into your Groq account and click on Create API Key. Give a proper name and submit. Now let's start installing the libraries. Here we used pip install -q, which is used to install Python packages with less terminal output. Q means quiet here. It will take some time to install all the packages. Now all the libraries are installed and you can ignore the error message. Now let's import our API key. we will follow these steps while building our application. First step is data ingestion. Instead of a PDF, let us take some text here so that it will be easy to understand. Now this text will be written into a file called data.txt. Next step, we are using document loader from LangChain community. This will convert any format of text to LangChain document object. So here the data we stored in data.txt will be converted into LangChain document objects. Next step is chunking, which is one of the important steps in RAG applications. Here we are splitting our text into chunk size of 200 and chunk overlap of 50. That means each chunk size is 200 characters. Here overlap is nothing but repeated text shared by consecutive chunks. We will store all these chunks in docs. After executing, below are the chunks that are generated. Now let's move to embedding step, where we convert each chunk into embeddings. Here we are using a free Hugging Face model to convert chunks to embeddings. Now the embedding model is downloaded. Now let's give the chunks we stored in docs and this embedding model to vector database. Here we are using Faiss as our vector DB. Here we are converting the vector store into a retriever that can fetch the most relevant documents for the query. Next is LLM model. Here we are loading our free Groq LLM model, Llama 3.3 with 70 billion parameters. It is free and more than sufficient for our application. I forgot to show where to paste your API key. In Google Colab, in key section, here you can paste your API key from Groq or any other source, and you need to enable the notebook access. Now let's move to query phrase, where you actually give your question. Now with the help of retriever, we will fetch the relevant chunks related to the query. So we will get a large output, but we will fetch only page content from our output, which is basically context, and that is written in the below step. So below are the chunks that we retrieved from our vector DB. Next is the augmented prompt step, where we will give our context and query to the prompt. I think I have not executed the above step, no worries. See, now it's got executed. Now the final step, LLM answer. Now we are invoking our LLM by giving the prompt. Now you can see the response for our question, what is RAG stands for. RAG stands for Retrieval-Augmented Generation. Like this, you can take any text and ask your questions. LLM will provide answers with the help of provided text. In the next video, we will take this project to the next level, where we will upload a PDF, and with the help of Streamlit UI, you can access the chat. Did you find this video informative? If yes, please comment and subscribe.